But we're going to start talking about velocity here. The first thing we need to do to understand velocity is get an idea for what speed is. People use speed and velocity like they're interchangeable in ordinary life, but to a scientist, they're slightly different. Looking at speed in one dimension, which is how speed really needs to be treated, let's do this by imagining an object that's moving, but it's moving in total darkness. And we can see it only when a strobe light flashes on it. So there's a video camera filming this object, sort of, but we only actually get to see where it is when the strobe light flashes. So once every second we get a snapshot of where it is. So this is what it might look like before it starts moving. It's in complete darkness, and we got a ruler there that apparently glows in the dark, or must be lighted or something. Watch the motion. Every second the strobe light flashes, and you see where the thing has moved to, and it looks like every second it's moving 1 unit farther away. Well, this is a graph that we might use to make a sort of a mathematical or graphical model of what we just saw. If we take time and put it on the x-axis as the independent variable, and the dependent variable is distance, we can make a plot that shows us what does this motion look like graphically. So again, here's side by side, we see the object in motion being filmed with strobe light, and here's the graph that will be a model or a representation of that motion. Watch the motion and watch the graph get built. Well, every time the object moves 1 second, it moves 1 unit of distance farther away. And so we have speed here. Speed, we've already discussed this a little bit in previous discussion. 1/1 is the slope, and speed is the slope of that distance versus time line. So we can think about speed as being that slope. And slope has units of something over something, and it's like meters or whatever this unit is divided by seconds on time, like maybe meters per second or centimeters per second. So let's define speed formally for the first time here, really. Speed, which we're going to call v, even though that really stands for velocity, is equal to the ratio of distance moved, so the change in the position of the object, delta d, or some people say delta x, divided by the change in time during the same movement. That's what velocity really is. Try this. Draw a graph of the speed of the object versus time from time 0 to time 10. Here's a blank graph. This could form the substrate of what you're doing. On a graph that looks like this, remember this is time now versus velocity or speed. I want you to try a graph here. Stop the video and do your best, sketch this out. Okay, here's what we should have found. Since the speed was consistently 1 unit for every second, it never changed. Speed is represented by a straight line that goes all the way across here from 1 to 10. My line's not very straight, not very good at drawing straight lines, but that's the idea. So your graph should look, if you're better at drawing straight lines, like this. Make sure you know why. Why is this flat when the other graph had a slope to it? If you don't know, go back and review, think about it, ask for help. Let's say this was the displacement versus time graph. So this is displacement, this is how far it's moved, versus time. And it's not a straight line anymore. There's some bends in it. This is a little more challenging, but I want you to do the same thing here that you did with the last one. Sketch a graph of speed on the y-axis versus time that corresponds to this object. Here they are, one above the other. Stop the video. Sketch this out. Take your best guess at what this is going to be like. Well, we can see here for the first second that it's going at a constant speed. From second 0 to second 1, it looks like it covers 4 meters in that second. So its speed for that first second is 4 meters a second. So I can draw that as a straight line for 4 seconds. Then it abruptly changes. And then from second 1 to second 4, we can see that it's got a different slope. It's got a different speed during this interval. And it's covering 2 units, it looks like about from 6 down to 4, 2 units in 1, 2, 3 seconds. So 2/3 of a unit per second. So that drops me down to here. And that goes on till second 4. So I can sort of connect the dots here. Oops. Starting at second number 1. And then at 4, it speeds back up again. The object accelerates, its velocity changes. And from second 4 till second 6, which is another 2-second interval, I go from 6 up to 8. So now its speed is at 1 unit per second. So I can jump back up to 1 here and go across to 6. So your graph should look like this if you draw better than me. Again, make sure you know why. If you don't know why, go back and review, and if that doesn't help you, ask for help.